In this video, we'd like to take up we'd like to start talking about what's called the definite integral. And we've talked about indefinite integrals, and an indefinite integral gave us a family of functions. For example, if I integrated x squared with respect to x, I got x to the third over 3 plus a constant of integration. So it wasn't just one function, x to the third over 3, it was x to the third over 3 plus 5, x to the third over 3 plus 7, x to the third over 3 minus 9. I got an infinite number of functions depending on what that value of c was. All right, in the case of a definite integral, we get a number when you calculate the definite integral. And what we want to do, we're going to have slick ways of calculating the definite integral in section 5, 6. But what we want to do is we want to understand the definition. Now, the definition it basically starts with what we call a Riemann sum. And a Riemann sum is chock full of notation. So I want us to first look at a couple of Riemann sums and try and get this notation down, and it'll give us, I hope, some insights into the definite integral, why it behaves the way it does, and such. So let's suppose that we want to calculate the Riemann sum. The sum is k goes from 1 to n of f of x sub k star times delta x sub k, all right, for the function f of x is equal to 1/2 x minus 1, where a, the left end of is x0, which is 1, x1 is 2.5, x2 is 3.5, x3 is 4, and x4 is b, which is 5. Okay, so I'm calculating this on the interval from 1 to 5. All right, and our x sub 1 star is going to be 1.5, x sub 2 star 3, x sub 3 star 3.75, x sub 4 star 4, and so on down the line. Okay, all right, now let's first of all talk about the delta x sub k. All right, so I'm starting here at 1. I'm going to draw a dotted line here at 1. Indicates where we start. All right, and notice that my x sub 0 is this 1. X sub 1 is 2.5. 2.5 is right here. So I have this first interval. This is going to be my first interval. It goes from 1 to 2.5. All right, so its length is 2.5 minus 1, 1.5. So delta x sub 1 is 2.5 minus 1, which is 1.5. That's the length of my first interval. All right, and that's what I call delta x sub 1. All right, x sub 2 is 3.5. So here we are, 3.5. And notice the length of the second interval is not the same as the first one. That's why we distinguish one from the other with a subscript. But it's going to be from 2.5 to 3.5 is 1, or of course we can calculate it by taking 3.5 minus 2.5, and we get 1. So delta x sub 2 is 1. Delta x sub 3, all right, or excuse me, x sub 3 is at 4. So notice here at 4, this next interval, all right, is going to go from 3.5 to 4. It's going to be a half a unit long. We could calculate that if it wasn't so obvious as 4, the right end minus the left end. 4 minus 3.5 is 0.5. Okay, and x sub 4 is at 5. And this is the right end, so notice this last interval, x sub 4, delta x sub 4 star, excuse me, delta x sub 4 is 1 unit long. It would be 5 minus 4, which is 1. Now, there's another concept that we need to keep in mind when we talk about these, and that is the maximum of delta x sub k, delta x sub k. And that's just what it says. All right, if I go through this, the first one is 1.5, second is 1, third delta x is 0.5, fourth is 1. Who's the biggest? Well, of course, the first one is the biggest, so the maximum is going to be that 1.5. That's the biggest of the delta x's. All right. Okay, so now let's go on. So we have our delta x's here. Now what we're going to do is we're going to use our x sub k stars. So out of this first interval, I need to select a place where I can evaluate the function. And in this case, we've chosen 1.5, x sub 1 star. Remember that first interval went from here to here. I have the line still. So x sub 1 star is 1.5, and so I'm going to evaluate the function here. And notice what that will do. That will give me, all right, a height of, well, applying this to this function, and we'll do that in just 1 second. It'll give me this height over this interval. So the area of this first rectangle will be this much. And let's see, what will that be? All right, well, that will be f of x sub 1 times delta x sub 1. Delta x sub 1 times f of x sub 1. All right, and let's see, what was our function? It was 1/2 x. 1/2 x plus 1. So if this is 1.5, f of x sub 1 star is f of 1.5, I'll say of 3/2, which is 1/2 times 3/2 minus 1. That's 3/4 minus 1, negative 1/4. I threw this in the wrong place. Okay, let me go back. 1.5 would be right here. I was at 2.5, and so then we would have been down 1/4. Okay, so our rectangle would have looked something like this. Sorry about that. So we would have had this rectangle right here. This rectangle right here. Notice here's 1.5, x sub 1 star. Okay, and this point down here is 1.5, or 3/2, and minus 1/4. And notice, so that the area well, what I'd say is I multiply the width times this y coordinate. All right, if I multiply the width times the y coordinate, I'm going to get negative 1/4 times 3/2. Notice that gives me a negative number, negative 3/8. Negative 3/8. So notice that it sort of is counting this area as though it were negative. All right, because it doesn't know. I mean, it's just multiplying things. All right, then my second x sub 2 star is 3. Okay, so 3, let's see, where will I be? Well, I'll have f of x sub 2 star is f of 3, which would be 1/2 times 1/2 times 3 minus 1. That would be 3/2 minus 2/2. That would be 1/2. So this is going to be the point 3, 1/2. And this will determine the height of this second rectangle. Okay, and so the second rectangle is going to be 1/2 high, 1 wide. It'll have an area of 1/2. So this second one will be 1/2 times 1, which is 1/2. Plus, now on this next one, I have 3 and 3/4. That's, I believe, 15. 3 is 12/4, and 3 more is 15/4. So that's going to be right here at this will be this next one. That rectangle, that will determine the height of this third rectangle. Let's see what that'll be. F of x sub 3 star is f of 15/4, which would be 1/2 times 15/4 minus 1. So that would be 15/8 minus 8/8, which is going to be 7/8. So this point right here, I put an arrow to it, is going to be 15/4 and 7/8. So this rectangle is 1/2 wide and 7/8 tall. So this is going to be 7/8, all right, times 1/2. Okay, and then finally the last one, we're at 9/2. Okay, so this is going to give me the point. This is at 9/2. So I'll be the point up here, 9/2, and then f of x sub 4 star is f of 9/2. That'll be 1/2 times 9/2 minus 1, or 9/4 minus 4/4 is 5/4. So this second quarter will be 5/4. So this rectangle, this last rectangle, will be 5/4 tall times 1 wide. And so this f of 9/4 is the 5/4 tall times the 1 is the 1 wide. And so let's see, I stopped here. This is going to be 7/16, and this would be 5/4. And so now if I look at this, I believe that this turns out to be, if I get the common denominator of 16, I'll have -6/16 plus 8/16 plus 7/16, okay, plus 20/16. And that's going to be 27/35, I believe 29/16. That would be the total area of all these rectangles. Now remember, when we say total area, we have to remember if a rectangle is below the x-axis, the Riemann sum treats its area as though it were negative. So anyway, so here's the picture of the Riemann sum. We have this first rectangle, negative, I forget what the area was of that, negative 3/8, -3/8, and then these areas have positive rectangles. This is important to realize that when rectangles fall below the x-axis, that their area is treated as negative. And then here's the computation for that we just performed. Okay, so there's one example of a Riemann sum.